This is Google Earth, and if we zoom in, believe it or not, this is a park bench. And here it is in ATAK. If you prefer Bing Maps, this is the same park bench. This is OpenStreetMap imagery, and our park bench is somewhere down here. But what if instead of looking like this, it looked like this? Okay, to do this, you're gonna need a few things. Number one, a drone of some kind. I'm using a DJI Mavic Air 2. Nothing special about it. I think you can get them used on eBay for 400 bucks now. You probably cannot use an FPV style racer drone. Number two, some kind of mission planning software. You can't run these by hand. You're not gonna fly these with the joystick. I'm gonna use something called Dronelink. It's about $30 a month. We will talk about some cheaper options later on in the video. Third, you need some kind of tool to stitch all the imagery together in an ortho mosaic or a map. I'm gonna use Pix4D Cloud. It has a free 15-day trial. After that, I think it's $50 a month. We'll also talk about some cheaper open source options towards the end of the video for this, but I'm using Pix4D because it's easy. Lastly, you're gonna need ATAK or Google Earth or whatever it is that you're gonna load this imagery into. First thing you need to do is set up Dronelink. So you need to install the Dronelink app on the device, whatever device you use to operate your drone, and you'll need to create a Dronelink account. Once you do that, you can set up the mission either in the app, or you can use the Dronelink in the browser at app.dronelink.com. Doesn't matter. Either way, it'll wind up on your device and syncing to your drone when you connect it to the controller. I'm going to create the mission in the browser. So we're going to go to create. I already have a repository here. You have to set up a repository. The first thing, I made mine private. Go to create. We're going to create a map. First thing it wants you to do is select a takeoff location. So I'm going to pick this gravel path here, and it's going to bring up a default grid pattern for you. Just grab the boundary points and set them to the area that we're interested in. In this case, we're going to grab this public park and water tower here. So you can set the boundaries, click done, click over here on the map itself and go to advanced, and we're going to fill all this in. So number one, select the camera. This is already set to my Mavic Air 2. The altitude, I tested this at 200 feet. We're not going to get into variations in altitude here, but the lower you go, the more detail you get, but you also might run into motion blur issues the lower you are. Front overlap, we're going to set to 85%. Side overlap, we're going to set to 80%. Capture mode is fine at photo. Photo type is single is fine. Speed, we're going to turn this way down to 5 miles per hour to avoid motion blur issues, because this camera is kind of subject to rolling shutter effects. Generally, the slower you go, the more clear the imagery is going to be. Obviously, the longer it's going to take you. Pattern, we're going to keep this as normal. If you set this to grid, you will get a double grid pattern and you will get higher quality imagery. We'll talk about that, and I'll show you an example of this later in the video of the difference in quality between the two. For right now, we're just going to fly a normal grid. And that's it. Click done. When you pull this up, if you did this in the app, it's already in the app. If you did this in the browser, whenever you pull the app up on your phone, you're going to see your map plan, so we can give this a name. You'll just pull this up in the app, and you'll fly it when you connect your drone. All right, go fly the mission. Wire up your controller to your phone or whatever it is that you use. Run Dronelink. You should see the mission that you just created available. We're going to go fly that. Set up your camera settings before you start. So I would not use an ND filter if you have that on there. Take that off. Set the shutter speed as high as you can. Set the ISO as low as you can. Make sure you set a fixed white balance and manual exposure. Basically, we don't want these settings fluctuating while we're taking pictures throughout the course of the mission. We want it all to have one look, so you get a nice, clean, consistent map all the way across. All right, first you will need a Pix4D Cloud account. They do offer a 15-day free trial that allows you about 1,000 images to process, which is more than enough to test it out. After that, I believe it's $50 a month. So create a trial account, get into Pix4D Cloud, and you should have a personal drive. You can create a project, and we're going to add a data set. I already have my data set in here, but we'll go ahead and add it again. So we're going to upload and process images. I think there were about 43 of them here. We're going to open that. It drops those in there. Go to next. I selected a 2D orthomosaic, and I selected quality. This does take quite a bit longer, but I was just curious what it looked like. Rapid is pretty fast, and you can test that out yourself. We go to next. We do not have ground control points in this case. We skip and process. This will take a while. I think mine took about 20 minutes. It will send you an email when it's done. All right, it finished processing. Let's take a look at what we got. So this was from an earlier one, and let's zoom in on that park bench we talked about. There it is. That is not bad. I can tell that's a park bench on a concrete pad. I can actually count that there are 1, 2, 3, 4, 5 slats, I guess, on the horizontal surface there. So we could go ahead and measure this if we wanted to. We could actually check what the length of this thing is. It says 1.725 meters. So taking a look at the rest of this thing, we have pretty decent detail, right? So pretty good detail in the grass here. If we go way in, we can actually see, you know, individual blades of grass there. We do have up here around this building some artifacting. This would probably be fixed by more images with more overlap or higher quality images, or running that double grid pattern. We can actually read the Kohler text on the top of that utility box. We definitely have some artifacting over here around the water tower. Again, we'd probably want to fly this and orbit it from different directions to catch all the sides, and we could create a 3D model of that water tower itself. But that's really just an artifact of kind of doing this quick and dirty. You do have really good details. So this is like a drainage gate or something here, but you can see actually individual pieces in that great structure there. A little more artifacting in the trees, but overall not bad. Again, this was a 6-minute flight, and I spent about 4 minutes prepping the mission and then 6 or 7 minutes flying it. So this is extremely quick and dirty. Frankly, the longest part of this was waiting for Pix4D to stitch it together. So we can compare this with the default Google Maps. So if you open up Google Maps, this is what you're used to seeing, right? It's going to overlay our map that we created right here, and we can compare the two, right? So remember, that was our park bench in Google Maps, that amorphous blob, and there's our park bench for real. So we can count slats here. Google Map default, you know, ATAK default imagery is just literally blurred out blobs of pixels here. So we have a massive, massive detail difference. If we want to load this into ATAK, all you have to do is go to Files and Export, Download, select Orthomosaic, and Format of GeoTIFF, and go ahead and download that. It will be pretty big. The one I have here, I think worked out to like 250 megabytes, but download that somewhere that you can then transfer it over to your ATAK device. So SD card, Dropbox, Megasync, whatever you use, download that file, put it on your device, and then we will just cover how to upload that into ATAK in case you're not familiar. All right, guys, we are over in ATAK now. This is, I believe, some USGS imagery that I pulled down once upon a time at, I think, 60 centimeters. Yeah, 60 centimeters. This is pretty typical of the stuff that I find publicly available for my area. This right here is supposed to be our park bench in this park. You know, not super usable. So let's go over the menu. We're going to import that GeoTIFF that we moved over to our phone. I'm going to take the second run that I did. This is the one where I did the double grid pattern because it's a little bit more complete and there's less artifacting. So we're going to go ahead and load that as imagery. And there it is. It detects it as, well, 0 centimeter, I guess. And we can zoom in, and there's our bench. Pretty good detail. This is actually max zoom in ATAK. I think in Pix4D and in WebODM I could zoom in further and see more details. I don't know if this is just a limitation on the imagery once it's exported or the interface in ATAK versus the mapping software. But in any case, that's pretty good level of detail for a 6-foot long, you know, park bench. This one has a lot less artifacting. You can see the building over here is actually in really good shape. You know, a little bit of distortion around that utility box there. This water tower over here is looking a lot better, much more complete with that double grid pattern that kind of fills in the missing images. And then I increased my overlap to 85%. And so I think we just have more tie-in points on the individual images here. So all in all, really good, much better level of detail. versus that a lot of the defaults. So I mentioned that there were some cheaper alternatives for some of the software. So for mission planning options, Dronelink is nice. It's $30 a month. It was very, very simple. There is an app called Litchi or Lychee, don't know how you say that. It's a $25 one-time app purchase. It does pretty much the same thing, doesn't have all the options that Dronelink has. Unfortunately, it also doesn't automatically do grid missions, like survey missions. There is a free tool where you can set up the survey mission. It'll map it all out for you, figure out the camera trigger points, and plan the waypoints for you. You can then export that as a CSV, load that CSV into Lychee, and then Lychee will go run that mission for you. So much cheaper, $25 one-time purchase, a little bit more work. The ortho mosaic side, Pix4D works really well, kind of out of the box. Pix4D Cloud does have some limitations. You can download the full Pix4D desktop software. That gets really expensive, like $200 or $300 a month, or $4,000 if you want to buy a perpetual license for it. There is something called WebODM. It's a fully open source and free. All right, guys, a little bonus for you. WebODM, this is an alternative to Pix4D, and it's free. So if you go to download, there's two ways you can do this. If you have a little bit of tech skills, and by tech skills, I mean, you know how to run Docker, basically, and clone a GitHub repo, you can do this for free. If you want, you can pay, I think, $57, and they will give you a Windows or Mac installer. I just ran this on a Linux machine since I had all this stuff set up anyway, and it worked right out of the box, no problem. Take a look at what this can do. This is super cool. So this is the generated map, same as we did in Pix4D, same kind of idea here with the 2D stuff. Pretty much just as good, and this is again from that double grid pattern, so we have better tie-in points, and we don't have as much artifacting here as we did before, and you can see the entire water tower is rounded out here. So what this could also do, I think you can do this in Pix4D as well, but the fact that you can do this in WebODM for free is really cool. So if we switch this to 3D, we get a full three-dimensional model here. This is a three-dimensional model generated from those photos. We got some holes, we're missing some images here. We could probably fix this with a full orbit of this particular point, but this is really, really good. And I mean, I've walked this path and I can tell you this feels exactly like being there in person. That's really, really, really accurate. So all around really cool, especially given that this took me no extra work. The software is free, and my entire effort in this was to draw some lines on a screen, sit for 20 minutes while the drone ran the mission, and then wait for about 45 minutes while this processed in WebODM. Now, would you want to do this all the time for really large areas? I don't know, probably not, but that's up to you. I'm giving you some options in case you want to explore and map certain areas with more detail than what you're getting from your typical satellite. There are a lot of other things we could do here. We could make the mission routes more efficient. We could process this stuff faster. I'd love to figure out ways to process this on the fly or even just at the edge or in the field to pull that information off the drone, create the orthomosaic, dump that orthomosaic onto ATAK and push that imagery out to people on the ATAK network. That'd be really cool. I haven't figured out how to do that or to do that in a relatively quick and efficient way. But if you have, let me know. I'd love to explore that more. That's it for now, guys. Do all the YouTube like and subscribe stuff, and I'll see you in the next one.